Have you ever imagined controlling all the lights in your home directly from your smartphone? Well, that's exactly what we are going today. Using an ESP32, an 8-channel relay module, and the Blynk IoT app, I will show you how to turn lights on and off from anywhere with just a tap on your mobile phone. Whether you are sitting on your sofa, at work, or even miles away from home, you can control up to 8 different lights wirelessly through the internet. So let's build our own smart lighting system and transform an ordinary home into a smart home. So let's get started. We will require the following components for this project: ESP32, 8-channel relay module, breadboard, and some jumper wires. Now let's take a close look at the heart of this project, the 8-channel relay module. As you can see, this module contains 8 individual relays, allowing us to control up to 8 different electrical devices independently. Each relay acts like an electronic switch that can be controlled by the ESP32. On this side of the module, we have relay terminals. These terminals are used to connect our lights or other electrical appliances. Each relay provides 3 terminals: common, normally open, and normally closed. For most home automation projects, we will use the common and normally open terminals so that the appliance remains off by default and turns on only when the relay is activated. One of the biggest advantages of using relay is that they allow a low voltage controller like the ESP32 to safely control higher voltage loads without any direct electrical connection. Now let's move the control side of the relay module. Here we can see all the interface pins. We have the VCC and ground pin that provide power to the relay board. Alongside them are the control input pins labeled IN1 through IN8. Each input pin corresponds to one relay channel. When the ESP32 sends a signal to any of these input pins, the corresponding relay switches on or off. For example, IN1 control relay 1, IN2 control relay 2, and this continues all the way up to IN8 controlling relay 8. By connecting these input pins to the GPIO pins of the ESP32, we can control all 8 relay directly from the Blynk mobile application. Connect the VCC pin of the relay module with 5V and ground pin with ground. Connect the IN1 pin of the relay module with GPIO pin 12 of the ESP32, IN2 with GPIO pin 13, IN3 with GPIO pin 14, IN4 with GPIO pin 27, IN5 with GPIO pin 26, IN6 with GPIO pin 25, IN7 with GPIO pin 33, and IN8 with GPIO pin 32. As you can see, I have connected 8 lights to the relay module, with each light connected to a separate relay channel. This allows every light to be controlled individually through the Blynk mobile application. Now it's time to configure the Blynk IoT platform. First, open the Blynk web dashboard and click on New Template. Give your template a suitable name and select the hardware as ESP32 and create the template. Once the template is created, navigate to the data stream section and click New Data Stream. Since we are controlling 8 different relays, we will create 8 virtual pin data streams. Assign them virtual pins V0 through V7 and save the settings. Next, open the Web Dashboard section. Here we will design our control panel. Add 8 switch widgets to the dashboard and link each switch to the corresponding data stream. This will allow every switch to control a separate relay channel. After setting up the dashboard, move to the device section and click New Device. Select from Template and choose the template we just created. Blynk will automatically generate a new device based on that template. Now open the device information page. Here you will find the important credentials, including the template ID, device name and authentication token. Copy these credentials carefully because we will need them in Arduino code. Open the code in Arduino IDE and paste the copied credential into the respective location. Now let's briefly understand how the code works. At the top of the code, we define Blynk template ID, template name and authentication token. These credentials allow the ESP32 to communicate securely with the Blynk cloud platform. Next, we include the required libraries for Wi-Fi connectivity and Blynk communication. We also enter our Wi-Fi network name and password so that the ESP32 can connect to the internet. After that, we define 8 GPIO pins of the ESP32 that are connected to the 8 relay channels. Each variable represents one relay that will control a separate light or appliance. Inside the setup function, serial communication is initialized for debugging purpose. Then all relay pins are configured as outputs. You will notice that all relay are initially set to high. This is because most relay modules are active low, meaning a low signal turns the relay on while a high signal turns it off. By setting all relays high during startup, we ensure that all connected appliances remain off when the system power up. Next, the blink.begin function connects the ESP32 to the Wi-Fi network and the Blynk cloud server. In the loop function, blink.run continuously check for command coming from the Blynk application. Now let's look at the Blynk write functions. These functions are triggered when a switch is pressed in the Blynk app. For example, when the switch linked to the virtual pin V0 is toggled, the Blynk write V0 function executes automatically. The command prm.asEnd reads the switch status, either 0 for off or 1 for on. The value is then sent to the corresponding relay pin. Notice the exclamation mark before the pin value. This inverts the signal because the relay module is active low. So when the switch in the Blynk app is turns on, the ESP32 sends a low signal to activate the relay. When the switch is turned off, the ESP32 sends a high signal to deactivate the relay. The same logic is repeated for virtual pin V0 through V7, allowing us to control all the 8 relays independently from the Blynk mobile application. In simple terms, every switch in the Blynk app controls one relay, and each relay controls one light or appliance, giving us a complete wireless control directly from our smartphone. Now let's configure the Blynk mobile application. Open the Blynk app on your smartphone and select the home automation device that we created earlier. Since it is already linked to our Blynk account, it should automatically appear on the dashboard. Next, tap the Add Widget button and add a button widget to the dashboard. Repeat this process until you have added a total of 8 buttons, one for each channel. After placing the button, adjust their size and position. To create a clean and organized control panel, you can arrange them in a way that make them easy to access and identify. Now tap on the first button to open its setting. Change the button mode from push to switch so that it remains in its current state until you toggle it again. Then assign the corresponding data stream to the button and give it a meaningful title such as device 1, device 2 or any name that matches the appliance being controlled. You can also customize the icon and appearance of the desired. Repeat the same configuration process for the remaining 7 buttons, linking each one to respective data stream and assigning an appropriate title. Once all 8 buttons are configured, your mobile dashboard is ready. You now have a complete smart home control panel that can independently control all 8 relay directly from your smartphone. Now it's time to test our smart home automation system. I have opened the Blynk IoT app on my smartphone and each button on the dashboard is connected to a different relay channel. First, let's turn on all the lights. I will press each button one by one. And as you can see, every light turns on successfully. This demonstrates that all 8 relay channels are responding correctly to the command sent from the Blynk app. Now that all the lights are on, let's turn them off one by one. As I press each switch again, the corresponding light turns off instantly. This confirms that we have completely control over every individual channel. Next, let's try a few random combinations. I will turn on only selected lights while leaving the other off. As you can see, the system allows me to control any light independently without affecting the remaining channels. I can create different lighting combination with just a few taps on my smartphone, and every command is executed almost instantly. This smooth and reliable operation shows that the ESP32 relay module and Blynk platform are working together perfectly, making this an excellent solution for smart home automation projects. And that's it. We have successfully built an ESP32 based 8-channel smart home automation system using the Blynk IoT platform. With this setup, we can control up to 8 different lights or appliances differently from our smartphone, whether we are at home or anywhere else with an internet connection. This project is a great introduction to IoT and smart home technology, and you can easily expand it further by adding voice control, scheduling features, sensors, or automation rules. I hope you enjoyed this project and learned something new from it. If you found this video helpful, don't forget to give it a thumbs up and share it with your friends. Also make sure to subscribe to the channel and turn on the notification bell so you never miss upcoming Arduino, ESP32, IoT and electronic projects. If you have any questions or suggestions for future projects, let me know in the comments below. Thanks for watching and I will see you in the next video.